Okay, are we in yet? So,
You're live, Steve.
thank you, mate. Okay, let's turn off. Hello, everybody. As usual, there have been some last-minute technical glitches. That seems to be life in the modern world. One of my screens decided not to work, but we're now rolling. So, 33 people waiting. Can somebody let them in, and we'll give it a go.
Steve, they're in. This is live.
Let's see. Thanks for being here. As you'd know me as Professor Steve Keen, the contrarian economist, but way back 40 years ago, I was a software reviewer for computer magazines, and I discovered a superb program that had used multidimensional data, but it had one weakness. It was all without a graphical user interface. And so I dreamt up one. Long story is why it didn't get introduced 30 or 40 years ago, but I've now developed it with the assistance of my great programming colleague Russell Standish, close friend and brilliant programmer. And this is now just Ravel. So you can see it on screen there. I think I'm hopefully on the smaller image that you're looking at the moment. I'm not looking at any screen at the moment, all of you. So I hope you're hearing me as we go on. So let's take a look. This is Ravel's interface, and the thing is, of course, remarkably enough, a thing called the Ravel, and that's a Ravel. I've just zoomed in here. It's the second icon, as you can see on the icon row here, where all the widgets that control the program are run. I'm not going to bother talking about the basics of the program, things like file and all this jazz. You'll see that being demonstrated. When you load Ravel, because this is such an unusual product, we've decided to have a little mock idea of what will happen when you attach data. So the basic idea of a Ravel is we have axes, which are dimensions, which show you what your different dimensions of your data are. So we have country, year, and gender here. If you want to see male data, then you have the selector on gender to go on male. Go up to female, you see the female data. If you want to see it by country rather than by year, you flip the axis around like this. If you want to see the sum of the data, you collapse the axis in that way. And that's the real key, the patented element of Ravel, which no other program has, that enables you to rapidly handle multidimensional data with ease. So that's the basic story of Ravel. And what I'm going to do now is just go through how that ends up handling data. So the first thing I want to show is just how we can use it for exploratory data analysis. And I'm going to bring in a data file now. We only import CSV at the moment. That's a limitation we intend transcending once we get some further development funds, which will come out of sales of the program, because we've done this entire Russell and I are using our own money and our own time. So I'm going to load a file here, and that's going to go looking for a CSV file. And what I'm going to use initially is very much in the news these days, and that's the consumer price index, what's happening with the consumer prices and inflation and so on. So once you choose a file and Ravel, it then attempts to interpret that file. What are columns in a CSV file data? And I'll quickly show you the CSV file here. Pardon me, I haven't got a file manager open. We had to move rooms rapidly, which is why I didn't have the data. I had it up beforehand via snafu. So the snafu was having to shut the system down and restart without the files all been chosen. And I'm just going to show the data file I'm bringing in here, which is house price data, and this is available from the Bank of International, which goes to do economic analysis, is a great source of free economic data, and they include data on house prices for about 40 or so countries. So if you load that data in Excel, this is what you see. And if you want to find the data itself, well, the data is way over here somewhere. So the columns that indicate the characteristics of the data, there's your country, whether you're talking in terms of real or nominal values for house prices, and whether you're looking at the index, which is 2010 equals 100 for all the data series here, or the annual change. And Okay, you've got that, and you'd say, well, where's the FT, which is a fair distance from column A? And I think you'd be struggling to decide what to do. Now, of course, people use pivot tables for that. We want to show that pivot tables are incredibly inferior to what we've invented with Ravel. So Ravel then looks at the data and so the first column is frequency, third is unit, and it guesses those are axes of your data, and then the remaining columns are all data. So it's guessed that data accurately. And I now then say, well, what's the horizontal dimension? That's going to be the date, which is the time dimension, and the format of that data is very, it's both yearly and it's so for that reason, I'm not going to specify the format. I'll let the program work that out. I click on import, and if we go back to Ravel, we now find there's the data file. The reason I had a subscript and a superscript, sorry, I had an underscore and a caret with curly brackets around the text that does that is so that I get Ravel's formatting capability to say, well, subscript CPI and superscript data, just to make it easier to read. Now, you can see I can move the objects around just by clicking on them and dragging, the usual thing for a graphical program. When I hover around the circle here, that's the output port for the data. And if I drag an arrow out of that towards the input data port on the Ravel, Ravel will then click to the nearest input port, and there's the data. Let's just zoom out a bit. So this is index data, monthly frequency, the date down here, and the country horizontal. I actually want to see it by date. Let's just attach a chart and rapidly see what we get out of that. So this is index data monthly. Let's go for the annual data. I'll show you why I want to do that in a moment. Drag this across here, and there's the annual house price data for Australia. And no surprises to anybody who knows this sort of off in the early 1970s. Let's take a look at a few more countries. There's Australia, Austria, Belgium, yeah. So you're going through all those various countries. So instantly you're doing something you might want to do in Excel and you'd be stumbling, how do I do it? It's automatically instantly done when you're working. And now let's take a look at the annual change in the data. And I just move the change over here and now I can see. So it's easy to find your data very rapidly there. I'm going to load another file, have another Ravel open. You can have as many copies of Ravel open at once as you have in your computer. And I've chosen, actually, let's go back and take a look at that one. Pardon me if I'm jumping all over the place because anybody who knows me on the Steve Keenan Friends show knows that I get rather carried away with my analysis. So I want to look at the UK, and that's down here. And I want to go back to the index because what we tend to think about in terms of inflation is that, and I've actually spoiled my surprise there, so pardon me blowing the surprise immediately. I just hope some of you weren't particularly observant. So there's data for the UK going right back, as you can see, to 1661. That's a hell of a long time series. And then you take a look over here and you can see that starting roughly in the 1950s and 1940s and 50s, having had stable prices for all these years, we suddenly have prices taking off. And the automatic reaction of many people would be, well, that's all caused by government money printing, central banks. We didn't have inflation beforehand. Now we have inflation afterwards. But let's just now take a look at the inflation rate data. And I want to just quickly, so that I can take a look at a different slice of the data in the Ravel itself and not lose what I'm showing over here. So I'm going to just call this CPI as a variable and attach to the CPI variable. And when I double click on the lock, it then selects a particular slice of CPI. Now, I also want to take a look at inflation. So I'll create another variable called inflation. Here, bring down another lock and attach that to the index. And now drag this across to annual change and lock that. So now I've got two variables, both with the one with CPI and the other with inflation. There's CPI. Let's take a look at the inflation data. And notice I've got the UK as the same variable. So this is date where frequency equals annual, or country is the United Kingdom, where unit equals change per annum. And up here I've got the same story, except it's the index rather than the inflation rate. Take a copy of that chart and paste inflation there. And that's the point that I sort of unfortunately signaled a bit earlier. The arbitrary or the initial result of looking at just the CPI would tell you, oh, inflation's caused by governments and we had stable prices beforehand. But take a look at the data. We had the highest rate of inflation in the post-central bank era was 25% back then. If we look in the 1970s, when we had, again, high inflation back then, it was 22%. But the highest rate of inflation in the pre-central bank period, 1800 was the date there. And at the same time, very rapidly, you have other extremes where the inflation is actually deflation. That's 1802, just 2 years later, and it's minus 25%. So rather than we having stable prices before central banks and unstable prices afterwards, and inflation is generally rising prices after the central banks and governments and all that jazz, but before deflation. And we're talking enormous rates of deflation at different times. So if you dive in here and take on, I'm trying to get the hint to turn up here, but we're talking 20% fall in price. Now, if you try to imagine what it was like for commercial activity at the time, that's immense instability. So what we've had after central banks and governments and so on came along isn't inflation, whereas we had no inflation beforehand. We have only inflation at a lower average rate than the inflationary period. What we've got rid of is deflation. So that's the sort of exploratory thing you can do with Ravel that I think would be rather hard to do as rapidly as I've done it with spreadsheets. I think anybody who uses pivot tables would also realize that we've got the results much, much more rapidly using Ravel than I would have got with a pivot table program. I think people using Tableau and Power BI and so on would still be getting to the point of being able to show this information compared to how fast I've done information exploration now. Now that's just looking at using Ravel as a way of looking at what you often want to do, and this is where Ravel excels, is do some deep analysis without getting lost in invisible cell reference formulas and without having data, a wall of data shown to you by the spreadsheet without knowing, well, how is that wall of data created? So I'm going to now blank this particular system here. And I'm going to load a different set of data. And this is going to be data on debt, which is another perennial issue. So this is going to be, again, for the Bank of International Settlements. I'm loading their data on debt. Again, I'll go sheet view of that. So I come over here and take a look at the debt data. This is the Bank of International Settlements data. I've trimmed it down a bit just to be able to show fairly not messy, but it takes time to say, I don't want to look at this column. I do want to look at another. I've just limited it to the critical columns rather than all the SQL database columns that are also stored in that original file on the Bank of International Settlements. So we have country here, we are the Argentine sector, general government, who's doing the lending, all sectors versus only national banks, valuation, nominal or market value, units, US dollar, percent of GDP, etc., etc. And where's the data? Again, it's way over here. We're now at the column HH. So again, with the spreadsheet, you'd be struggling to work out how do I actually access this data and do some analysis with it. The wall of numbers gets in the way. Let's try it again with Ravel. So I've got the data import form there, and I might actually, I've managed to lose that form, so I'll just bring in a new one. Same story, bring up the form, and then choose the file. And now I'm choosing the debt data, as you saw a moment ago in Excel. Ravel then goes through and interprets those columns. So, well, the first is a dimension, which is country. Second dimension, the sector doing the borrowing. Third, who's lending. Fourth, how's the valuation? Is it the face value of bonds or the market value? And what's the unit? And then horizontally, let's drag this out a bit further here. You can see all the years starting from the second quarter of 1940. Click on next, and now again the horizontal dimension is date, and I'll give that, so that's a time dimension, and the format in this case is just a single format. So I import that data, and now let's attach a Ravel to take a look at that. Again, I can zoom in, that's using the scroll keys to do it. I can also use these keys here to zoom in and zoom out to original scale and so on. So this is a rather more complicated data set, and you can see that I've got valuations, we've got nominal value or market value, sectors, all sectors lending or just banks, the sector doing the government, general, government, non-financial sector, households, etc., the various units. So let's just take a look at this in an analytic sense. Again, it's normally you're going to want to look at things by date, and I want to look at date by country. So I'll flip country around here to take. Hang on, let's do it this way because I've got one country there. I've got to have all the countries selected to have Ravel put the data where I need it to be. I know I'm going too fast here. This is typical me, and I can't see any reactions as well, which is why I'm probably still racing. But the way the Ravel works is you can have as many dimensions like we've handled the data with 30 separate dimensions rather. But what Ravel outputs initially is what is stored in the down pointing and right pointing axis. So when I've got date by country, that's going to be the first slice of the data that's taken out from here. And if I attach a sheet, for example, do this, stretch a sheet out, attach this out here, what I'm seeing now is date by country, as you can see. If you want to see it the other way, simply flip the axis and they turn around. Now, again, I know you can do that with a pivot table, but I think any pivot table experts here would concede it takes a bit longer to do that in a pivot table than it does with Ravel. Let's take it back again by country. I'll just delete that sheet so I can do a bit more working here. And what I want to show is what caused the financial crisis back in 2008, because you may not, most of you will, a handful of economists who predicted that the financial crisis is going to happen before it happened. So what was I looking at that let me see that happening? And Ravel makes it much easier to expose this data than what I used back in 2006, which was a mathematics program called Math. The choice when I first realized that the crisis was coming. How do I analyze this? Do I use spreadsheets? Do I use MathCAD? No way I'm going to use spreadsheets. So I use MathCAD. But Ravel is far more powerful than what I was using in the mathematical programming world. And let's just take a look at why. So what I've got here is debt and percentage of GDP by country, by date. I'm going to look at the private non-financial sector. I'm going to look at money lending by all lenders, and I don't really know whether nominal or market value is going to be the biggest one there. Do one thing which is a central role in analyzing multidimensional data. I'm going to collapse this data and say, just give me the maximum value of the two, whatever the valuation is. So let's now take a look at that data, and I'll start with the United States of America, because of course that's the country that is the, let's zoom in a bit here to get the dot more easily. Okay, that's the key one where the crisis began, of course, and had the most dramatic impact. So I now going to drag from the output port of the Ravel to the input, and there's the private debt level for America from 1945, 23, 24. Okay. So you can see the rise in the private identified was that this ratio of debt to GDP couldn't continue growing. When it ceased growing, there'd be a crisis. And that's why I decided I had to warn about it, because I wanted to analyze in Hyman Minsky's financial instability hypothesis, and a major factor in Minsky's theory is the importance of private debt and its rate of change. So that's the level of private debt. Now let's just label that. So I'm going to take a label, take a lock over here and call this debt, and I'll just make a abbreviation, debt priv and percent, so that it's percentage of GDP. So that is now named. I now attach this, and I'm going to also make it not just the United States, but all countries. So drag this back inside here, you're going to see all those countries turning up over here. So it's debt in the private sector for all the countries in the database. And if I right click, and by the way, one little hint for Ravel, if in doubt, right click. We do an enormous amount through the right click menu. So this says as dimensions, there's 335,43. That means there's 335 quarters of data, which is most of the way towards a century, 75 years, and 43 countries. So what I've now got in this one variable is effectively what would be the contents of about 12,000 spreadsheets. That's private debt as a percentage of GDP. I can also look at private debt in domestic currency. So I'm going to, and you can see now that's changed over here because that's what the chart attached. I'm almost certain this is going to be Argentina's currency because there are, Argentina's had such massive inflation. So this is now going to be debt, priv, and I'm going to use D for domestic currency. Here's the variable. Bring down another lock. Attach that to the lock. Okay, so now I've got debt in domestic currency, debt as a percentage of GDP. I'll just delete this chart here and wire up this one over here for percentages, which is going to be all those countries again. Now, what I want to Minsky's financial instability hypothesis point of view is that what causes a downturn is a huge plunge in credit, where credit is the annual change in private debt. And I can work out the annual change in private debt quite easily by taking debt in domestic currency and putting it through which is this delta object here. This says I'm going to look backwards a number of quarters so that I get annual change. So I've now attached debt in private debt in domestic currency to the delta operator, and I now need to edit the delta operator. This is the axis I want to look at changeover is date. And I want to look back 4 quarters, and that is now going to be the annual change in private debt, which I can call credit. So now I've got credit, and there are now I've got 2 monitors going here, and when I right click down low on the screen, the menu occurs on my second screen. So I'm just going to put this Ravel back into this mode, or hang on the part, get it out of editor mode, so it's smaller. Move the right click here, you'll see there's now 331 quarters here and 43 countries, whereas over here in the private money it was 335. So I've lost 4 quarters, of course, because I've got to look at the change over a 4-quarter period. So I've got credit. And now what I want to have, just to make it relate to the level of debt as a percentage of GDP as well, is I need to have credit as a percentage of GDP. There's just one problem. I don't have GDP data. Well, you could do this in a spreadsheet. You could do it in a pivot table program as well. But let's just look at a bit of mathematics here. This is debt in domestic currency. This is debt as a percentage of GDP. If I divide debt in domestic currency by debt as a percentage of GDP, the debt numbers cancel, and what I get is GDP in domestic currency. So I can just attach these 2 wires here, and what, of course, I'm dividing by, let's say, like the top debt level over here is 250%. Well, that's 2. So what I'm doing is I'm actually dividing by 250 rather than 2.5. I'm getting a number which is 100 times too large. out of that. Simple solution, put it through a percentage operator. And Ravel makes, and we will try to make it as simple as possible to put, you don't have to go up and click up here. You can, and you can choose the percentage operator there. But I just type the percent key on the screen, and Ravel will then place that on the screen, which hasn't happened because why? There we go. Okay, there's percent attached here. And now I just, since this is GDP, gross domestic product is going to be in domestic currency, so I won't point having DC as a top element there. So now I've got GDP, and there's now GDP for 43 countries over 335 quarters. Whoops. Okay, pardon me, wrote the wrong. But GDP, I can take a copy of credit up here and now divide credit by GDP. And now I want that in percentage terms. So again, I'll type another percentage operator and put that through here. And now I've got credit in percent of GDP. Attach that variable here. And now I've got the information I need. So let's just tidy things up here a bit. That's why I didn't get the percentage key earlier. I left it up on the top of the screen. I'll just delete that later. Go back, standard view. By the way, the design canvas I'm working on is effectively unlimited. The way that scroll bars work is that it's interpreted as 10,000 pixels one way by 10,000 pixels the other, but you can have 100,000 by 100,000 pixels. There's really no limit to the size space. So what I want to now do is look at credit as a percentage of GDP, and I want to look at debt as a percentage of GDP as well. So I'm going to take a copy of that chart and place it down here and take another one. So I've got charts which are identical sizes here and by country. So what I need is another Ravel to control that. So I notice, by the way, Ravels, when you first attach a Ravel, it's the expanded edit version. We have those hints there as well. After that, we show it in compressed version. And I'll just actually put it into edit mode here so you can see it's by country. Has reduced the complexity stored up in this Ravel, which had 6 dimensions. We're now down to just 2 dimensions, which are the only ones we want to work on. So there's a country by date. I'll attach credit to another Ravel. What I want to do now, move from one country to another, I make the same changes in both Ravels. So I rubber band here, click outside the Ravels themselves, and you'll see I've got this option down here, link selected Ravels. So I choose that, and now whatever I do in terms of country on one will be chosen on the other. So you can see me doing that. So I now attach these to one chart and this to the other. At the moment, I'm getting all that information. Let's look at the United States of America. And the financial crisis. You can see that credit reached 15.5% of GDP, 15.7% of GDP at its maximum halfway through 2006. It then plunged down to minus 4. Just trying to get the hint of it's going to be minus 4% of GDP. So the huge plunge in credit from positive and actually the highest level, as you can see in the post-war period, it was way back in 1947, it was 7% of GDP, and you had periods where it fell to 3%, during the 1990s, 2.66, but the highest level by far in the post-war period was 15.7% during the subprime boom. So that all that money was being lent out, ninja loans and all the other irresponsible things the finance sector was boosting aggregate demand in the economy, boosting aggregate income and causing a boom. And then when the bust occurred, when people started to go up in the ninja thousands, then we had a collapse. And that was the global financial crisis. Now, let's go through the countries. I've done it for the United States here, but I've also done it for the UK, Turkey. This will show us the financial crisis, the 1997 crisis, by the way. in Asia. Do you remember the Asian financial crisis? So this analysis doesn't just apply to the United States. And I've done it with one formula. This formula here uh, for all the countries in the database. This is divided into the GDP for all of the countries, and the analysis makes sense of events which mainstream economics still can't understand, and yet it does it with an incredibly simple set of formulas. So this is something you can read, which is not something you can do with Excel spreadsheet formulas. It's complicated with pivot table formulas because I think if anybody knows their pivot tables, referring from one pivot table to another, getting the formula references becomes extremely tedious. Here it's all quite straightforward. So to read through this equation, private debt and domestic annual change is credit. They have debt and private currency divided by debt and domestic currency, divided by debt as a percentage of GDP. Put through a percentage operator is GDP. Divide credit by GDP. Put that through a percent operator. You get credit as a percentage of GDP. And on the screen, and this is something anybody can read. If you're a mathematician, you can read these equations. So all this work is being documented for you as you put the system together. And there's also a summary tab, which is structured and very well formatted. And you can see all the definitions are provided automatically. So auditing, which is a sheet, is quite straightforward with Ravel, and that's one of the major advantages. If you're an auditor or an actuary and you're trying to analyze, you want to be able to document what you're doing, you're probably working very hard at the moment to do that using spreadsheets or using a program like Power. Ravel will do the documentation for you. And then if you want to present this documentation to somebody else, let's actually start doing that now. This is a fairly ugly chart at the moment. Let's just, I'll just drag these up the top here so I can you appearing on this screen rather than the one below. So I now want to use options here to label this. And this is going to be debt to GDP by date as percent of GDP. I'll just make that the capital up there. You can control the pen styles as well. Let's make this slightly thicker. And if I wanted a legend, that I'd attach the legend there, but I'm doing country by country. So, and you notice I'm wasting a fair bit of space here. That's because we use the same interface for our dynamic simulations, and we want the simulation point to be turning up not at the very end of the chart, but that wastes a bit of space for a display chart. So we call this, again, everything is graphical in Ravel. Just type the constant 2025. I might give myself a bit of range and say as much as 2030 and as little as 2010 with a step size of 1. And I can now attach that as a number. I'll just flip that around. Trying the and that then tells Ravel to use the full width of the chart. I'll make it say 2030. We get a bit of space there. Recalculate, and there's some of the control we have over formatting the data. I'm just going to delete that chart and save myself a bit of time by copying this one down here, and I'll attach that down over here. Let's just spin the wire, and I'll rename this as credit to GDP. Attach that, and now I can see credit. And again, I'm losing a fair bit of space there. So I'll start in, say, 1950. Pardon me. And I'll give myself a bit of a range. So say maximum 90, minimum of 1940, step size of 1. And I'll just attach that to both the credit line and to here and move that around a bit. Bend the wire. let's now move a few years, let's say for 1960. Okay. And that's Thailand, because Thailand doesn't have data going back as far as the United States. And now I want to put those on publication tabs. So if I right click on the object and I say add to publication tab, there's only one at the moment, and do the same here, add to publication tab. The menu is now turning up on my second screen. So you see that where you are. Go to the publication charts there, and I could now output this to the auditing section or the account section and so on, and have a different display for another one. Let's say I type this and call this credit, so I simply show the credit data. And I can now go back over here and say, place this on the credit tab. If I go to credit, then there's just the one object there, and I can zoom around and so on and so forth. Now, it's possible to export this to other programs. We want to make Ravel for a large number of users, but of course, sometimes you want to put this in a word processing document or a PowerPoint display or that sort of thing. So what you do in there is choose File, Export Canvas, and you can export as a SVG, a vector graphics file, PDF, encapsulated PostScript, a PNG file, a bitmap, LaTeX as well. LaTeX is actually for the equations themselves, and you can export a model from MATLAB. So that's a rough view there. Let's just actually tidy things up here a bit. So put that in editor mode as well. You now have something which, again, I'm doing this on the fly to an audience which I can't see. So I'm doing some fairly messy work overall. I tune this, I produce something that is quite aesthetic, that is informative to users, something that's extremely hard to do with spreadsheets. You've got to work around the limitations of the cell format. Ravel just gets rid of all that stuff and lets you design, do your analysis, and show the data. I've only been showing mainly showing graphs so far, but let's take a look at a spreadsheet. And you can see I've got data from 1940, there's almost no data held back in the 1940s. Only a couple of countries have that data. Let's then, what we can then do, I'll just move this up so you can see my menu, and I right click, and I want to show the final slices of the column. So it's actually 23, 20 there. Put that, for example, so I've got it by the highest level of depth, and I can attach another Ravel, delete the wire here, attach this over here, put this in editor mode, and then, so let's just say take this here, so drag it out to this here, and then right click on the country menu. Again, you can't see what's turning up on screen, so I'll drag this up so you can actually see it on screen here. And so I want to sort the axis by value. I'm getting caught up with too many overlays there. Let's sort by value. I'm not getting it to work. Okay. There's always something that doesn't work in a demonstration. I'll try down here in my other menu. No, I don't know why I'm not getting that. So I'll have to explain that later. But it is possible to right click on the menu and choose sort by, now it's working, sort by value. And I want to make this reverse statically. And now I get the highest level of credit. And it's amazing. It's the winner is Argentina, and then Turkey and Russia. I think you can see it. So I've now sorted the data dynamically. I can take a slice out of the data. There's a whole lot of operators I haven't shown. I'll just actually quickly show some of these here. Let's say, for example, I want to see the top 5 countries. Then one of the options up here is to take a slice, which is what that operator. I'm going to flip that around again. changed the direction of objects a short while ago. Delete that wire, attach this in through here. So at the moment I get everybody. But if I right click and choose edit on that particular widget, then I can, again, I choose the axis by country. And so I want to see if they're the top 5 or top 6, that'll do. And then hit recalculate. And I then see the 6 top countries in terms of the level of credit for that particular year. So that was a very fast demo through Ravel. I hope it's reasonable for you to analyze and see what I'm doing. And I'm waiting, let's see, there's many other issues to cover. So I'm just going to hope that we've got some questions coming in from some of the audience to try and get some feedback. And I'll just also stop now. Thank you for stopping sharing screen. So high speed, but I think Ravel's got, I hope you can see the immense potential of Ravel. It's also extremely cheap at the moment. We were still experimenting with pricing, and it was a small operation. We've decided to distribute as a membership thing, but basically buying the software because Patreon takes care of all the VAT issues for us for every country on the planet. So if you want to check out Ravel, you can sign up on www.patreon.com/Ravelation and get a copy. And we hope we can maintain that price level. We have no real costs at the moment, so it's easy for us to do that. And we'll see how effective the distribution is. If you like it, please sign up on www.patreon.com/Revelation. If you're curious, but you don't want to commit just yet, there's a 7-day trial. And during this, because you've turned up to watch the show today, if you send an email, as Ty has told you here, to Steve Keen and Friends at gmail.com, during this live stream, I'll send you a 60-day limited version, so you can trial that for a couple of months and see what you think with your own data. Happy to take questions now, so I'll hand over to Ty. Hope there are some questions.
Yes, there are. Can you hear me okay, Steve? Yeah, so we've got more people that want the download than we do have questions. So you're going to have a busy time over the next 24 hours replying to emails. So thank you guys. I do have them. Give us about 24 hours, 36 hours to get back to all of them because we're doing it manually. So we haven't forgot about you, and I have them all. We do have some questions, but like Steve says, you can get the 60-day kind of limited edition through the email that you sent. And in the upgrade button in the software itself, that'll lead you to the Patreon page where you can sign up $7 a month if you really like the software, which is really a minimal price compared to other software packages out there. So I'll get to the questions. Steve, just let me manipulate Restream here and press some buttons and bring up the questions. First one from Stephen Hoy. Steve, what was the ancient spreadsheet called Javelin?
Hey, look, there's somebody who asked that question.
Stephen Hoy.
Okay, I think I know you. I think your name is familiar. Very perceptive, because when I was a software reviewer for Australian Computing Magazine, which was a McGraw-Hill outlet back in the 1970s or 80s, and as part of a couple of companies sent me software all the time. I'm going to relax now because it was pretty stressful giving that demo. I've never demoed something I've actually created before, which I'm trying to sell. So it's a bit funny experience. So I wish this was Scotch. It's only water. But anyway, companies were sending me software left, right, and centre, and I had about 6 meters wide, I think, and about 4 meters high, and I had a wall of software. I'm not joking. 6 meters by 4 meters by 3 layers. And I remember having a famous hacker at the time come and visit me. Looked like a hacker, is stone and long hair and all this sort of jazz. And he walked inside my room and saw this wall and just sort of transfixed like this. And I humble bragged and said, "What's the matter? Haven't you seen that much software before?" He said, "No, I've just never seen that much legal software before." Anyway, so one of the packages I got was Javelin. And for those who don't know Javelin, it actually should have been called Trident, because a javelin, if you've ever done sport, which I have, a javelin, of course, has got a single point. A trident has 3 points. And this used the idea of a trident to aggregate data. So you can have your Doubleday store and your Vaucluse store and your Penrith store, and then they would be the 3 points of the javelin, and then they would be aggregated along the shaft of the javelin, and therefore would add up over time. And I remember remarking in my review that, it's pretty good. It was a graphical user interface way back in the early 80s, I think. But obviously there are mine. So a company saw me say that, a company called PC Express, and they sent me their software. A company is called Information Resources Australia, and they sent me their software, which is owned by a French firm. And this was a multidimensional database. I was blown away by how powerful it was, not just one, I think 12 dimensions, but it didn't have a graphical user interface. So in response to me knocking Javelin for being a graphical user interface with only one dimension, I then got this multi-dimensional database with no graphical user interface. Long story, I invented the concept of Ravel way back in the 1980s. And so that particular shape, the reason I've taken so long to get to the stage where I'm developing it is because I didn't have a partner who was a top class programmer to turn my concept into an actual program. And now I'm working with Russell Standish, who, apart from being an incredibly close friend over 30 years of friendship now, he's also he ran the high performance computing unit at New South Wales and Sydney universities. He eats tensors for breakfast. All the data analysis, all the manipulation, sparse data arrays and nature to him. So when we started collaborating on Minsky, we decided also to collaborate when I ceased working at the University of Western Sydney to collaborate on Ravel as well in our spare time. And that's what we've done. So yes, Javelin, very, very good point. I'm most impressed.
All right, we've got another question here from Horror A. Can Ravel join two or more CSV files similar to SQL?
You bet your bottom dollar. And of course, what you've reminded me is that I've left that part of the demonstration out. So what I might do is do that. Now, it's going to take me slightly longer because I'm going to have to go through loading two together. But bear with me. So let's just take a look at doing that. So that's a very good question to ask. So I'll go back to sharing my screen again and share the entire screen up here. So let's now go and take a look. What have I got live at the moment? So credit to GDP. Now, this may take a bit of time to load because I'm going to load in a International Labour Organization unemployment database, which has 500,000 columns. This is a database formatted in classic SQL format. So let's just take a look at that. And go and get the file. This will take a while to load given its sheer size. So where do we have it? It's unemployment rate ILO. Open that. And let's just take a look at the data itself to show you what I'm talking about here. And that's where are we? Unemployment rate ILO. Load that into Excel. Okay, so what you've got is country. Let's just take a look at the column more carefully. Sex total, sex female, sex male. Age groups, there's a whole lot of age divisions there. So youth, 15, blah, blah, blah. Dates and the observation value. I'll hit the control arrow again. There's 592,000 rows of data there. So that gives you an idea of the scale of information we can handle in Ravel. Is 2 to the 64, but we're actually going to go beyond that. We're adding in a future version, which hopefully will be completed sometime this year. We're going to have, I think it's going to be 2 to the 128. That just means you can You could have a data atom in the universe. Not that you need it for analysis, but we just want to have that capability. So this is saying you've got country by sex, by age, by date, by observation value. And the date is, again, the formatting is year and dash quarter. So click on next. This will take a while to load properly. And watch the weights. This does take a while because it is a large data set. Reading the data in. You don't have to go and make a coffee. By the time you made a coffee and came back, it'd be well and truly loaded, but it does take a while.
Okay, well, while that's loading, here's a former student of yours. Look at your restream. Christian Delanes. Hi, Steve, former student from Kingston. Please, my greetings from Rome.
Lucky Christian, good town to live in. Thank you. I recognise the face, not the name, but the face. So, yeah, Kingston was one of the great tragedies of being a critic of mainstream economics is that you only get to teach good economics at low-ranked universities, and Kingston is quite low-ranked. But I had a pleasure of teaching for about a 4-year period there, taking a non-mainstream book. So, Christian, thank you very much. And just if you can fill in a bit, just let Ty know your email, because you'll do that to get a copy of Ravel. And I'd like to know what you're up to these days in Rome.
And while it's still loading, we'll go to another question here from John Watkins. I assume that, like pivot tables in Excel, it uses the headings as variables. Is it possible to run simple regressions?
Yes. What we've been working on, there's a huge amount of programming time by me as well in the program over the years. And what we were doing is making sure we got the data system right. So we had a version of Ravel way back in 2018. That's, as we're talking, by the way, that's now data has come in. So I'll just attach it here. So we spent our time making sure the data model was correct. And the limitation of the system back in 2018-19 was we didn't have sparse data handling. And what that meant was if you had a 10 by 10 array of data, then each element took up, say, 8 bytes of data, or had data inside it. And that, of course, made it a huge limitation on just how big a model you could actually load into RAM. So a huge amount of work has gone into making sparse data handling. So you only use data if there's actually, you only use memory in the computer if there's data element in the array. So getting all that right took an enormous amount of time. And therefore we didn't get around to doing things like regression analysis until very late. So if you look up here, and I haven't spoken a lot about the widgets, but I'll go through them now. These are horizontal pop-up menus. So if you click on the plus, all the binary operations, so adding 2 or more elements together, adding and subtracting, multiplying, dividing, minimum, max, yada, 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 all the way out here. Fundamental constants here, so e, pi, 0, 1, infinity, and the percentage operator, unary operators, percent, e to the x, log, etc. Summation operators here, progressive summation operators, so progressive sum, progressive products. And then here we have our statistical operators, which we've only just started adding. And you notice the very last one here is a linear regression. At the moment, we will have every form of regression you'll want, logistic regression, exponential, etc., over time. But we simply wanted to get the foundations right before we got to that level. What I'll bring down, is this will be useful in the demo I'm doing on comparing 2 data series here, is the correlation coefficient. So let's place that there in the meantime. The program might object if I don't actually access it when I try to recalculate, but I'll find out the hard way in a moment. So I'm going to drag this lot sideways again because of the sheer amount of memory. You will get the setting key. I've got credit to GDP for the United States there. To simplify things for presentation purposes, I'm going to put this by date, by country, and I'm going to choose sex to be total and country to be United States. So I have in here so I can select it more easily. I think this is sorted by alphabetically. United States of America, total by age. So the age group, let's take a look at youth to adult. That's 15 to 64. Okay, so that is now unemployment, USA. I'll lock it just to make it so that I can make other changes later if I need to the Ravel without changing that variable. So that is now date where country, United States, where sex equals sex total, age with youths, blah, blah, blah. Let's just attach that to the other side of the chart there and recalculate. And that is supposed to be no correlation whatsoever compared to according to conventional economists. And I think you can see it's almost like a Rorschach plot. When credit goes up, unemployment goes down and vice versa. Let's now do a correlation coefficient there. So I can now just from over here in one and attach that from unemployment here. And let's put a data object down here and see what the correlation coefficient is. And over the entire post-war period, arguments not conformant. This is a problem. Okay. What we should be doing is saying, well, it's dates, and let's make the dates the same. So what I've got too many variables coming out of here. I'm just going to cheat by putting yet another Ravel in the way here. And I'll just delete that line. Ravel makes me very cavalier with because it just has such flexibility in handling layout of objects. The gentleman in the background is Tyrone Keynes, great friend and the world's greatest Minsky modeler, as he describes himself, quite legitimate. And he lays beautiful designs. He spends far more than I do, but I'll just quickly get this set up so that I can get around this particular issue here. So let's just make this into editor mode as well. I'm now going to link these two Ravels. I've got to recalculate so that the date data, right click and choose link selected Ravels, and then add a caliper. This is our way of selecting a slice of data. I haven't shown that yet, so this is a good question to be given. So it's going to zoom in and choose 1990 to 20, say, and now they are going to be conformant. So they're basically the same number of data elements are going to come out. So I can now do my correlation coefficient there and whack the two together. And now it'll be conformant, and the answer is the correlation is minus 0.89. This is one I get so frustrated by having to deal with mainstream economists, because according to mainstream economists, and I could quote one guy, you might know the name, Ben Bernanke, he said that absent, well, it's a long prelude, but he basically said there should be no significant economic out of changes in private debt. Well, bullshit. Okay, I'm getting a minus 0.89 correlation coefficient there, R squared about 1.75. This is clearly, credit is a major driver of economic performance, and what you can see in the chart is conformed here. Now, what I could do, if I use the analysis there, then I could do a linear regression on the two as well, which should be quite straightforward. And as time goes on, Russell will be spending his time not getting the foundations fixed up because they're already absolutely rock solid. Going to be adding bells and whistles, et cetera, et cetera. So you can do all that. Thank you for a great question. Enabled me to show a couple more points of Ravel that I should have shown earlier.
So I don't know. We kind of we kind of answered that question there. You showed that we can do regression. So thanks, John. We've got another one from Horror A. Besides summing across all values in a dimension, can Ravel be selective and sum only across a subset of items?
Yeah, absolutely. So I haven't demonstrated that again. It's a good question to get. So you can do selective in various ways. You can put criteria, so only particular elements are exported out of a Ravel, or you can do it manually. So like I've got just the United States there. If I drag this back down into the selector box, then I can thank you, Ty. I can right click and choose to pick axis slices. You'll then get a pop-up menu, which is turning up here, and I can say I want to say let's take countries that had hyperinflation, for example. So I'm going to want Argentina, Barbados, etc., etc. So I'm taking a subset, Dominican Republic, blah blah blah, and then what I've now got is only a minor number of countries coming out of that element. So you can do selection manually, and you can also select by putting various sort operators through, and then only the ones which are outputted by the Ravel, and you can then do the work on those. We're going to be improving that. We do it at the moment, but I want to improve how well we do it and how many various forms of selection we can do as well. But yes, that power is in the program.
All right, we've got another question from John. How does Ravel handle multiple time-based data files with differing periodicity? For example, if one file has monthly data, file 2 has quarterly, and file 3 has annual data. Thanks.
Good question again. Nice to have a very intelligent bunch of people asking questions about the program. I think I've got one showing up here. That's the house price data. Let's see. I want to take a look at that. And I think that's got the feature you want to take a look at. So no, it doesn't have frequency there. The CPI data does. So hang on a second. I'll just actually load the CPI file. Let's see, where's that? Debt and GDP. Okay, I've got to go back and choose open. So that's inflation data. Programs complaints. There we go. Okay. There's CPI data. Now notice let's just take a look over here. I'll move these around a bit, get a bit of space for the object itself. So you'll see this has got data which is monthly and data which is yearly, annual. Okay? So we've actually imported data in both formats in one file. And what we do is when the data comes in, I'll show the annual versus, I've got CPI annual there and CPI monthly already selected there. If I take a copy of CPI annual and then CPI monthly, then I can put them on one chart if I feel like it, which will not be particularly informative, but you'll see the capability of those different objects, the Ravel, and right click it. And I'm sure Ty is groaning as he wants me to do dreadful layouts here, but it's all on the sake of getting stuff done quickly. CPI monthly here as well. Rubber band those. Choose to link the selected Ravels, and then for the annual data, let's just take a look at a particular country. See that's not sorted. I'll start with Japan. That's a fairly fascinating one, but I've got to get the right country. I'll just right click and choose sort axis forward. So I've now got them in alphabetical order. And there's Japan there. Okay, and then that's the annual data there, and that's the monthly data. You won't see much of a difference, of course. Okay. But there are the two, you can see the two time series have been imposed one over the other. What we do when we take the data is we store it in ISO standard format. So if let's just take a look at the numbers here and see how they turn up on the screen. And you can see it's the 1661, that's the beginning of the data. Let's go to the end of the data. So I'll just actually right-click here, row slices, and go for, hang on, it's turning up on the wrong screen, so I'll just actually drag this up there a bit. Do it again. Row slices, head and tail. So that's the 1660s to 2040s. No data's turning up there because that's coming out of the annual data. Let's just delete that wire, and I'll attach the monthly and actually stretch it out a bit. Not sure what's sending up blank there. There's actually data in that spot. But yeah, an ISO standard, quarterly, daily, whatever else. Oh, there we go. The numbers are turning up now, so you can see the CPI data turning up for Japan at the end of that time series. So we handle all time dimensions. This is one of my major frustrations using spreadsheets, because format the data. A particular column is going to be, time data and monthly or quarterly American format or whatever else, but it's pretty kludgy. We actually understand time, and there are some ways in which I want to improve how well we handle time. So one little example for which will turn to actually use the program, a hint if things don't work out properly. If you have a quarterly data and you specify quarterly data, then program handles it fine. If you have quarterly data and you don't specify that it's quarterly, so you don't actually tell it the format, it will interpret 0, 1, 2, and 3, or 1, 0, 1, 0, 2, 0, 3, and 0, 4 as January, February, March, April, which is wrong. So we're going to be fine-tuning that. So if it says Q, then 01 means March and 02 means June, and so on and so forth. We haven't done that yet. So if you do get chunky looking charts of what's going on, specify the format to force Ravel to map that across to the months of the quarter, January, April, whatever else your country uses. We have to do a bit of fine tuning there. But yes, we do handle all time series. We actually understand time. We don't yet have time as something you can do calculations on. So we do want to have data which can actually, rather than just being sheer numbers, can also be dates, and then you can look at changes over time. These are some of the improvements we're now going to be adding now that we've got the rock solid foundation right, and will be very. It's already better than Excel with time.
So I've been getting the Johns confused here. So I've got two questions here from John Rodat. The first one is there a limit on the number of dimensions, and what effect do more dimensions have on calculation speed and overall capacity?
Yeah, obviously the more data you have, the more processing time will be taken. The fact that this is written by a guy whose company was called High Performance Computing, who set up the High Performance Computing unit for the universities of Wales, means that he's somebody who knows how to handle hypercubes of data. And so we have loaded data in with up to 30 dimensions, and with when you look at the number of potential data points in it, it ended up being molecules there are in the universe. But of course, the more you add, the more it slows down. So you would have seen when I was showing the ILO data there with 500,000 rows, it took a while to load the data in. It was actually quite responsive once I had the data inside. I find that it's to push the program to the stage where it freezes or appears to freeze. You might take 5 seconds to recalculate occasionally, but because our equations are, equations working on vectors and matrices and higher dimensional tensors, enormous amount of processing going on very, very rapidly. So I think again you would find you'll occasionally wish it was faster, but you won't be screaming that it's too slow.
All right, we'll give one more question to John Rodat, and this, I guess, is a suggestion for you, and I think it'll be good for you to kind of speak on the development of Ravel. And it is, Suggestion for later refinement of the graphs as the user scrolls through different elements of the dimension. It would be great if the header of the graph reflected the specifics.
Definitely. That's actually one of the current tickets we have for redesigning it. So at the moment, I'll just bring up that's a good point to talk about with the charts. By the way, we don't support pie charts yet, for example. That's one of the things we need to add. So we come into options here. Where's the form? There you go. Okay. So in pretty basic, you simply enter text inside here. The text itself has a certain amount of flexibility. So, for example, I want to talk about prices. I can type delta, for example, the Greek letter. Hang on, /delta. Let's go back to the beginning and make sure that's okay. Click on OK there. So you can see I've got the Greek character up there at the moment. So we have more flexibility than just typing simple English text inside there. But what I'd like to have is, because I have America as the output country, CPI for America, et cetera, and then you chart CPI for UK, et cetera. So we definitely want to add that, and that will happen. As I said, because we've had one of the beauties of this program, isn't it's taken us a decade from the original concept to finally having a saleable product. And we've had one program we're working on it. I'm only part-time because we were doing this as a private venture, and we have to pay for cornflakes. So Russell was working on 2 or 3 other projects and putting in part-time efforts for a number of years until about a year ago. We were both a bit on the old side, as you can tell. I'm 71. Russell's younger than me, but he's hit retirement age. And what that means is he's putting a full-time effort to Ravel now. So rather than, say, 10 hours a week, we're getting 40, 50, 60 hours a week of a top-class programmer. But we left the bells and whistles to the very end. So that's a bell and whistle as far as we're concerned. And therefore, we don't look as good in terms of our charts as you'll get at Power BI or Excel and so on and so forth. And for that reason, that you export data, of course, export CSV and then load those into those programs. But we do intend dramatically improving the gloss and the look and feel of the program. The first items will be able to, like you do in Excel, you can reference a particular cell to be the title of a chart. Well, we're going to have putting in the form, you can say, country, curly brackets, and will then show you the country name as a substitution. So yes, definitely very, very useful feature to add. If you sign up and pay us that $7 a month, then that will fund us to be able to hopefully hire a couple more programmers. And because, as I said, one person's done almost all of the design. We have a team of 2 now. Russell, who does the C++, Niels Radmacher. Maybe Niels is watching, I hope. Russell's asleep at the moment, or he's driving his car from one town in Australia to the other, I think, at the moment, so he couldn't take part. But Niels is doing the JavaScript end of the program. And what we have is a pure foundation, no compromises, no kludgy work by one person who's not quite as good as code as another. It's all got the same quality foundation. And then when we want to add in the bells and whistles, it'll just be the bells and whistles that are delegated to our as we expand the user base of Ravel. It'll be Russell who's checking off on it, so I can guarantee the quality of the code.
All right, we've got another question from Horror A. I don't know if we can answer this one. Maybe Steve, what he's talking about. I'll bring it up here. Does Ravel have DDE, enabled dynamic linking to a Word report, etc.?
Not as yet, but that is clearly something you want to do. Ravel itself, by the way, is a DLL, a dynamic link library. So it's built on the back of Minsky, and Minsky, it still exists inside Ravel. So Minsky is a system dynamics program feature we call a godly table for enabling you to model financial dynamics using double entry bookkeeping. So that code is all in existence. You can run both Minsky and Ravel as a command line program. You can script it. Scripting can be done. We currently have scripting in an old Linux language called TCL/TK, And what Russell has done recently is port it across, so now scripted in Python. So what you could effectively do at the moment is call Ravel within Python and then use that to program and produce the output you want, producing a Word report and things like that. But we will add DDE at some point. So we've got the foundations right. We well and truly know how to do that. So that will be a future feature.
Okay, so this kind of segues into more of a Minsky question, but I thought I'd put it in there because it reminds me of using the godly tables for other things than financial products. I'll put the question up from Audacity. This may be a strange question, but I was wondering, do you think godly tables would be useful for tracking and balancing other resources but besides financial? Can units be tracked? Steve?
Yes, yes. Like the funny thing is, the person who's re-asked that question, Tyrone Keynes, is I think probably the best person at using units inside Minsky anyway. I'm a bit sloppy on that front because I'm doing it as teaching and doing things rapidly. I don't often include units in my programs. Tyrone almost always does. So units are an existing capability of the program. And if you make an error, you try to do a calculation which, for example, is like adding meters to seconds, then Minsky will warn you are making a unit error. Raw numbers, raw scalars, they're typed, so you can't make a typing error in Ravel and Minsky at the moment. In terms of godly tables, what godly tables work with is exclusive categories. So, of course, if you are doing a financial transaction and you're taking money out of one account, it goes into another. One goes down, the other goes up. There is that guarantees that you are doing the tracking accurately. But equally, and this is where Ty and I first met, I realized that I could use godly to simulate the pandemic because if you there were a very popular model in epidemiology is called the SEERD model, and that stands for susceptible, exposed, infected, recovered, dead. And you're either susceptible or not susceptible, you're either exposed or not exposed. So they're exclusive categories. So the godly table trick there be used to handle transitions from one state to another. Now, equally, if you think you're running a factory and you have the warehouse materials in beginning production, the fabrication unit, the paint shop, etc., etc. Each of those, your car is either in the paint shop or it's not in the paint shop. So you could easily use the godly table exclusive categories to handle modeling production through a car factory, for example. So yes, you can do it. We've already done it, and I'd love to see people extend.
All right, we've got a question from one of our normal weekly live stream viewers, Mo Nanaran.
Okay.
Are there guidelines to prepare data for Ravel? I'm guessing preparing the spreadsheet itself.
Yeah, yeah. There's a help system which got a long way to go. I've got to be honest. I wrote the help system in LaTeX, and it took me a while. And it's good, but it's not brilliant. I've got to improve that. So you do get assistance there. We have a tutorial file to help as well, giving us some ideas. The main thing is that each Ravel. I'll go back to you can go back and share the screen again, Ty. You need to get a unique identifier for each element. So you can't have two identifiers. So if I, for example, I try to bring this BIS data here, and I'll do this just to indicate what can go wrong. And so let's see, file should already be chosen. But that's it there. Ignore the country or ignore the frequency, for example. Then that is going to mean that I'm going to have Sweden and two values for Sweden. If I try next and import, Ravel complains, duplicate key. Okay. So what you have to have is, and of course, that's not what that was, I knew I was making a mistake when I did that. So what you have to be sure of when you're doing a selection is that the selection gives you a unique identifier for each element in the overall system. That's the vital thing. We are adding budgets, I might say, where if you had like let's say you've got data which didn't specify who your customer was properly, and then if you had 4 or 5 customers from the one suburb, and then when you tried to get unique values, you would get, we are going to produce a pseudo identifier as part of the system. But another thing which can happen here is when you have a duplicate key, what do you do? Well, at the moment, we throw an exception. However, you can also say, well, I want the sum. Okay. And what that means is you could take, imagine you've got transactions for literally every sale you've made every day going back for a year. You're going to have 34 sales on one day, 28 another, 500 on another day. You don't want the individual sales, you want the sales per day. So what you'd say is give me the sum, and you would sum over the various dimensions. We need to fine tune this to some extent because at the moment we sum according to the time dimension you're working with. If you're working for daily data and you choose sum, you're going to get the sum for the days, but you might want to analyze at the monthly level just to get away from the volatility of daily data. We haven't added that yet, but we will add that. That's the main thing. You must get a unique identifier. If the data you're taking in gives you non-unique, then you know to say how you want to aggregate that. You can do it by sum, product, minimum, maximum, average.
All right, we've got one more question. We'll keep your Ravel up. We've kind of touched on it already, but we'll just kind of show what we can do with the plots at this point. It looks amazing. Does Ravel have different ways of presenting data, area graphs, etc.? So maybe you can show our dot plots, our straight lines, our area graphs, just to show how that worked so far in Ravel. And of course, more will be added as funds come in.
Yeah, it is limited on that front at the moment. So the types of plots we support are, you can see we've got line charts I've used exclusively here so far, bar charts, scatter plots, and lines plus symbols. So that's the limitation we don't there. We don't have area charts and things of that nature. We actually are not very far from having country charts because if you have a geo identifier, it won't take us long at all to be able to add geo charts there. So you can have charts where you see the map of the world and you show the relevant bar and so on and so forth. So that's where the bells and whistles come in, and that's where your support, financial. If you can use Ravel, pay us the incredible sum of $7 a month. That will give us the money to be able to partly pay Russell for his time. If we get, we will then be able to hire additional programmers and add all those features under Russell's overall guidance. So yeah, that's the one area. You said we put all our work into the foundation, very little into the bells and whistles, because we wanted to get the foundations right. Because I find with programs like Excel and a lot of the pivot table, Tableau and stuff like that, you're working so bloody hard to get the data the way you want. You get ecstatic. But what really matters, I think, is being able to analyze the data properly. We've put the effort into analyzing properly first, over time, to make that look as sexy as possible for your marketing manager.
All right, that's about it for the questions. Just to everybody, I've put the email stevekeenandfriends@gmail.com. Give you another 5 minutes to email us so you can get your free 60-day limited edition copy of Ravel. And like I said before, we'll try to send all those emails out within the next 24 hours. We've got to do it manually, so be patient with us, and we will get to you. And so, yeah. And also, Steve, what is the Patreon website where you can purchase Ravel, the monthly subscription?
Okay, that is www.patreon.com/Ravelation. It's actually, I'll bring up the little guide here, something that I wanted to cover here. So let's go back to let's see the screen. That's it there. So www.patreon.com/revelation. And I'll just actually bring it up and show it everybody. Let's just take a copy of that and go across to browser and pop it in there. And that's it. So, accept all the cookies. So all you need to do is to choose, and then there are two types of membership. There's the Explorer, which is where you've actually decided you're going to. So the Explorer is where to decide whether you want to commit, and then there's the Fan, and that's you already decided you like it. Paying $7 a month immediately, you get the program straight away. So that's the website, www.patreon.com/revelation.
Beautiful stuff. All right, Steve. Any final thoughts you need to articulate?
No, I'll just put my face back there if you wouldn't mind, Charles, so I can see the audience. So maybe I've got to make a change myself. Hang on. Over here. Yeah, okay. Look, thank you everybody for turning up. I hope you enjoyed what I've shown you so far, and you can see the potential that Ravel, the potential it has in the future. I used to pull what little hair I have out now, out working with programs like Excel, and pivot tables. I just find, even though obviously I've got the brain power to cope with them, I couldn't imagine a more kludgy way to handle data than a pivot table. So I designed this because this is what I want to do, to analyze data. And I every time I try with the Excel spreadsheet, even working with hypothetical data. By the way, Minsky, Ravel can handle that. You don't have to bring data inside. We have in the parameters, you can say where you have or a function like iota, which gives you an incremental number starting from 1 or starting from 0 and going forward. You can make up hypothetical sales numbers that way and do, break-even charts and stuff like that. It's all quite feasible. I just don't want to touch. The only reason I touch Excel, okay? So it's got great power, great flexibility, easy to understand, self-auditing. All these things are existing methods. That's why I think it's worth your effort to dive in and learn a bit of Ravel. And I think once you've dived in and got your feet wet with it, or pivot tables again.
All right, everybody. Thanks for joining in, and we'll get the Ravel copies out to you. Thank you, Steve, for spending your Tuesday evening where you are giving this presentation. It was very insightful, and we will be back with the live stream. I know there's a lot of live stream watchers, our weekly watchers. We'll be back in September. So if you're wondering where we are, we're just taking the summer off. And we'll see you again in September. All right, guys.
Please tell your friends. Okay, we're relying upon viral marketing. My marketing budget is 0. I'm relying upon my social media. You are my socials. Please, if you enjoy it, share it with your friends. Get them to sign up as well, and we can get to being market leaders with them for marketing. That's what I'd love you to help me do.